In safety engineering, 1 out of 2 redundancy is a classic starting point. You have two sensors monitoring the same thing. If they agree, everything is fine. But if they disagree, the system assumes something is wrong and immediately shuts down. This is perfect for fail-safe systems. Think of a traction control system. If a speed sensor fails, the safest thing is to turn the system off and let the human driver take over. It's safe, but it's not always available. But what happens when turning off is actually dangerous? Imagine a brake-by-wire system. If a speed sensor fails while you're cruising at 100 kilometers per hour, you can't just disable the brakes. You need the system to be fail-operational. It must detect the fault, isolate the broken element, and keep working correctly using only the healthy sensor. To do this, we have to improve our 1 out of 2 architecture with diagnostics. This is where ISO 26262 comes in. In Part 5 on hardware development, the standard gives us guidance on how to prove our diagnostics are effective. Table 9 in the Annex D provides examples of diagnostic coverage for sensors. To move from fail-safe to fail-operational, you typically need high diagnostic coverage. This means your system must be able to detect over 99% of possible failures before they cause a hazard. Without these diagnostics, your 1 out of 2 system won't know which sensor to trust when they disagree. What exactly should these diagnostics look for? According to the standard, you should check for stuck-at faults, drifts, oscillations, range violations, and gradient inconsistencies. Moving to fail-operational is about more than just adding a second sensor. It's about the intelligence to know which one is telling the truth. By following ISO 26262, you ensure your system stays available when it matters most. And who knows, 1 out of 2 might be not enough for your safety case, and you would need 2 out of 3, or even better redundancy with high-coverage diagnostics.